This tutorial will introduce you to the fundamentals of vector geometry as they relate to the rest of this week's topics on transformations in Grasshopper, intersections in Grasshopper, and more complex types of geometry such as NURBS, curves, NURBS surfaces, and meshes. But before we get into any of that, we need to understand how these fundamental objects like vectors, points, and planes work, and how we define them in Grasshopper. So to begin with, you can think of a vector as defining direction and magnitude in your Grasshopper definition. So they're very useful for performing transformations on things, like moving things, because when you move something you need to specify a direction for the thing to move in and how far it's going to move in that direction. And also scaling, when you need to specify ratios for how large things need to change or how much things need to change. Or rotations, when you need to specify axes that things rotate around and angles for them to rotate. So to create a vector in Grasshopper, the simplest way to do it is to use an object in the parameters toolbar and then in the geometry tab and then one of these for vector parameters, and this just lets us set a vector in Rhino or reference one in Rhino using a line. So to set a single vector, we right click on our little parameter, we choose set one vector, Grasshopper disappears, and we're left with the Rhino viewport. So you can see what it's asking for up here is the end point of the vector. We could also change the start point, or we can specify unit vectors, which I'll mention in a little bit. So it's just asking us to specify the direction and the length. So I'm just going to click somewhere in my viewport, and that information will be stored in this component. Now I mentioned briefly before, I think, that vectors are described using 3 coordinates. Typically, if you're describing a 3D vector, which is what we're usually working with in Grasshopper or in Rhino, they can have as more dimensions, so you can have a 4-dimensional, 5-dimensional, 6-dimensional vector, or they can have fewer dimensions, like a 2-dimensional vector, but typically we're working with 3. So to view those 3 coordinates, I'm going to create a panel component. I double click because I'm in the habit of it, but you can find it up here in parameters and then input, panel. We can connect our vector up to the panel, and by default the panel will display these 3 coordinates. So I have a vector which is currently invisible that has 8.42 something units in the x-axis, or it has a component of 8.42, an x component, 7.50 in the y, and 0 in the z. So this is always ordered in x, y, z. By default, Grasshopper doesn't display vectors because it would mess up your viewport pretty quickly. But if we really need to preview that vector, there's a component which lets us do that, and that's in the vector menu, and the vector tab, vector display. And we connect our vector up to that, and we need to provide an anchor point for the preview vector. I'm just going to use the origin, and it will display this vector for us, just as it was doing when we were setting that vector in that component. So if we set a different vector, then our vector display will update. Sometimes we're less interested in the magnitude of a vector, and we're only interested in the direction. So Grasshopper has some specific components for achieving this functionality, which is the creation of unit vectors. So a unit vector is just a vector with magnitude 1. So if I connect my vector component up to a unit vector component, which is up here in the vector tab, and then plug that into my display component, you'll see that it's changed the length of the vector, but it hasn't changed the direction at all. if we look at the coordinates, those coordinates have scaled down. So they'll still be in proportion to keep that direction the same. Now, why would you ever want a unit vector? Well, one common reason for wanting unit vectors is so that you can specifically set the length of something. So sometimes it's quite quick to set a direction, and then you want to move something exactly 5 units in that direction. Well, you can unitize the vector and then multiply that unit vector by some scalar value, and you'll have a vector which has a length of 5, say, but the same direction that you specified earlier. Grasshopper also comes with some unit vectors for describing the axes of your Rhino coordinate space. So in this vector tool panel we also have unit X, unit Z, unit Y. So let's create some of these. Fairly self-explanatory what these look like. You connect up an X unit vector, you get a vector which is pointing in the X-axis with a magnitude of 1. Now you can change that magnitude. I mentioned before, maybe we'd want to set it to 5 using the only input to these unit vector components. So you can set the unit multiplication so that we have a vector which is pointing in the direction of that x-axis with a specific length. Again, in later tutorials this is going to be really handy. So a point is also described using 3 coordinates, but unlike a vector which is typically used for specifying direction and magnitude, points are typically used to specify the position of something. So let's go back to our parameters, tab, geometry toolbar, point object. Drop one of these down on the canvas. Again, we'll right click on it, choose set one point, and just place the point somewhere in our Rhino viewport. Grasshopper displays them as this little green cross. And if we connect it up to a panel, you'll see that it also displays these 3 coordinates. So you really can't tell the difference at all between a vector and a point in terms of how that object is described in Grasshopper. Because they're basically the same thing, you can cast between them. In other words, you can convert a point to a vector. It's the same thing. It looks like we lose a space, but otherwise it's exactly the same thing. And back to a point again, without any problems at all. Now another interesting object which we're going to be working with a lot is a plane. So vectors, to reiterate, describe direction and magnitude. Points usually used to describe position. Planes are typically used to describe orientation. So if we go to the vector tab, the plane toolbar, we have a whole bunch of components for creating planes. Now to create a plane, you need to specify both an origin point, which is the location of a plane, and the direction of its 2 axes. So using those 2 axes, it'll describe an infinite 2-dimensional plane in space. Just like we have unit vectors, we also have some fairly common components for describing planes, like the XY plane, which is the same as the one we see in the Rhino viewport, the XZ plane, the YZ plane. So let's create one of those, see what it looks like in the viewport. So planes just preview as a little grid. By default, these components locate at the origin, but you can locate them wherever you like. So maybe we use this point that I just set up before. So unlike vectors, planes do have a position in space. It's kind of like combining, quite literally, a point and 2 vectors together to produce a slightly more complex object. So we'll look at creating one using a point and two vectors. So in our plane tab, we'll find the plane component. Slightly more complex than one of these simple components here. I'll hide this one. We'll use our point as our origin, and we'll just right click on these inputs to specify some other vectors. So we can specify a vector for the x-axis, and watch how this red axis of the plane will change. So that changes the coordinate space of that plane. And we can specify an axis for the y. So I'll just specify a 3D one here. And you'll see that we've created a two-dimensional plane from those two vectors in space. Now we're going to look at some fundamental mathematical operations on vectors in Grasshopper, specifically just adding two vectors together. Now, since vectors are described numerically using 3 coordinates, to add vectors together, it's essentially the same as adding together sets of numbers. So we're just performing basic mathematical operations on the vector geometry. So we'll create two vectors from our parameters toolbar. Using the vector object, we'll set one vector. We'll create another vector object. We'll set one vector. We'll go to the vector tab, and we'll use the vector display component to preview these two vectors. Now I'm going to be cheeky here. I'm going to display one vector from the origin, and I'm going to display another vector. Rather than using the origin, I'm going to use our previous vector. So its anchor point is the tip of this first vector, because this will give you a little hint about how we add vectors together. If you did trig or something in high school or at uni, then this is going to be quite familiar to you. If not, then there's a simple visual trick for remembering or guessing what the product of adding two vectors together will be. So how we add two vectors in Grasshopper is, well, there's several ways to do it, but let's look at the fundamentals first. To add two vectors together, the product of these two vectors is going to be the x component of the first vector added to the x component of this second vector, and it's going to be the y component of the first vector added to the y component of this second vector. Same with the z components, and then those three sums will be used to describe the third vector. So just from me moving my mouse around on the screen here, maybe you're going to be able to intuitively guess what that vector might look like. So we need to somehow access the components of these vectors. We could preview them using the panel, as we did before, but without some fairly advanced knowledge of how to play around with strings, which I'll teach you later on, we can't do too much with that. So Grasshopper provides us with some components for decomposing a vector object into its component parts. So it's in the vector toolbar, vector panel, decompose. So let's drop one down and connect it up to both of our vectors. So sorry, I'm dropping two down here. And try and get these visualization things out of the way. Okay, so we can use a panel again to have a look at what's coming out of these. We've got a single number for the x, the y, and the z for both of these vectors. Now we can add them together, as I mentioned before, so we can go to the maths panel. It's just a simple addition operator. We add the x components, copy this down. I'm just holding Alt and dragging, that copies. we add the y components, and we add the z components. And that'll give the sum of each of these three components. Now back in the Vector Tool tab, Toolbar, Tool Panel, we go to the Vector menu, and just like there's a Decompose component, there's a Create component from those three parameters of a vector, which is a fairly consistent pattern in Grasshopper. Typically you'll have components that break things up into their smaller parts, or you have components which construct objects from smaller parts. So this is a constructing component. And you'll see that the input's pretty similar to the outputs of this deconstructing component, or analysis component if you like. So we connect up the product, or the sum of our x, the sum of our y, the sum of our z, and that'll produce this vector. So let's grab our display, hook up this last vector, and you'll see that it's describing this new vector from the origin to the tip of our second vector. So this is the geometric solution to adding two vectors together. It's called the tip to tail. So you take the second vector, you place it on the tip of the first vector, and that'll allow you to describe the result of the addition, which is what happens when you add the component parts. Now this is kind of quite annoying. You have to use quite a few components just to add two things together. So in the newer versions of Grasshopper, which is what we'll be using, the addition operator also works on vector objects, so not just on numbers. So if we connect just the two vectors together, it's going to perform what these components do and give us that resulting vector. We can just check that by plugging it into the display, and there you go, it's exactly the same. This tutorial comes with a matching Grasshopper definition that you can download to see all of the examples which I've just covered, and there's a lot of other components which are quite interesting that you guys should check out in your own time. So what we haven't looked at are some of the grid components, some of the more complex plane construction components, some really interesting ways of creating points using different coordinate systems, and also for analyzing points relative to other geometry, and some components for evaluating and analyzing vectors. So make sure you check these out.